Assalamualaikum and a very good day to Dr. Nurul Fadila. My name is Nurjasma Izri binti Jamaluddin. In this video, I will be presenting about my research project entitled Light Responsive Behavior of Liquid Crystal Monomer. Next is the overview of my presentation, where I would start first with the introduction, followed by literature review, and lastly would be methodology. Introduction. Liquid crystal monomer, LCM, was initially discovered in 1888. It is a state of matter that flow like liquids but are composed of anisotropic compounds. Since the discovery, LCMs were widely studied and applied for display devices due to their wavelength altering abilities, and this undoubtedly contributes to the emergence of LCD technology. According to Kim and Jung, one of the materials required by LCDs is to obtain the optimum optical quality is light, because light is a stimulus that can control the molecular ordering or disordering of LCMs. Problem statement. Photoisomerization of LCM is important for LCDs applications such as computers and televisions. However, the selection of light parameters such as a wavelength have a significant impact on photoisomerization, and according to Aikida and colleagues, based on their research, some studies have been performed, for instance manipulating the wavelength of light. However, achieving the desired functionality and behavior of LCMs at once is difficult, and the current LCM research focuses on the chemical structure and molecular alignment control which employed in the LCD application. However, before determining which type of LCMs to use for the application, it is vital to understand and distinguish how LCMs respond to light. And different types of LCMs exhibit different responsive behavior. Hence, it is crucial to analyze the differences so that it is clear how each LCMs analyzed in this study can benefit the LCD's industry further. The main objective of this research is to study the light responsive behavior of LCM. So the light or responsive behavior of LCM is investigated further in order to compensate for the lack of research on monomers, as most research concentrates on LCP, which is the liquid crystal polymer. Based on the background research and the problem statement, the first objective of the research is to analyze the responsive behavior of liquid crystal monomer towards light, and the second objective is to compare different types of liquid crystal monomers. This research analyzes three different types of isobenzene monomers. The responsive behavior of liquid crystal monomers to light is the main focus of the study. UV spectrophotometer will be used to observe the light responsive behavior of the liquid crystal monomers. The light responsive behavior of the liquid crystal monomer is studied by considering the parameters associated with light, including wavelength, intensity, and absorption.
Next, I will be explaining my literature review.
Liquid crystal plays a key role in a wide range of technologies ever since its discovery. According to Ishihara and Mizusaki, liquid crystals have anisotropic physical properties such as refractive indices, dielectric constant, elastic constant, and viscosity. Following this, the liquid crystal shows birefringence because of its anisotropy. Optical properties and textures can be differentiated by liquid crystal phases. Liquid crystal phases are classified into three phases known as nematic, cholestric, and smectic. The schematic diagram of the phases can be seen in the upper right of this section. The phases are based on the arrangement of molecules in a mesophase or its symmetry. In a nematic phase, the molecules have long-range orientational order with molecules parallelly arranged in the plane. Due to its negative birefringence, the nematic phase is beneficial for LCDs with wide viewing angles. The cholestric phase is identical to the nematic phase. The only difference between them is that the cholestric has no long-range positional order of molecules center of mass, resulting in a weak tendency of molecules to align with each other. Smectic A and smectic C have focal conic texture characteristic, and as stated by Fu, LCD with this texture are being developed due to their low power consumption. Liquid crystal monomers are monomers that have liquid crystal properties and typically contain aromatic rings as mesogens. The inclusion of light-responsive materials or chromophores into LCMs improves the performance of the molecular photoswitches. In line with this, the light-responsive monomers become a hot topic among researchers. The light-responsive monomers are appealing due to their fast and reversible response, which is essential in applications such as optical switching, actuators, and data storage. Photoisomerization is a process where the trans isomer will be exposed to UV light and it will transition itself to cis isomer, is shown in the diagram. Meanwhile, a suitable wavelength of light or thermal energy can cause reversible isomerization, where the transition from cis to trans isomer will occur. In addition, in the photostationary state, PSS, an equilibrium between the trans and cis isomer is identified. It can vary depending on the wavelength used for irradiation, as determined by the quantum yield of photoisomerization. Besides, the reverse isomerization will also occur when the sample is left in the dark after radiation, which increases the absorbance as the sample is transitioning from trans state to cis state. A variety of chromophores such as azobenzene, stilbene, daryl-ethene, and spiropyrin are used as photoresponsive stimuli of LCMs. Azobenzene and stilbene both can transform from trans state to cis state, and according to Newkirch and a colleague, they state that the trans isomer reacts slower than the cis isomer for both azobenzene and stilbene. Besides, daryl-ethene and spiropyrin closes the open ring when a molecule exposed to UV light and open the closed ring when exposed to visible light during photoisomerization. Among the chromophores, azobenzene is widely used as stimulus due to its easy synthesis, high efficiency, high quantum yields, and quick response. Next is the current research on the light responsive of liquid crystal monomer. The photo-induced phenomena in which light itself is used as a stimulus to change the molecular arrangement in a liquid crystal system has been a growing field of research in recent years. Dudford and colleagues have reported that when an optical device is made up of bent-core material, it can last up to 12 hours. They also mention how good the contrast is between the bright and the dark states. According to Shishido, one of the appealing applications of liquid crystal and azobenzene mixture is the hologram. He also stated that by adding the amplifying components such as cyanobiphenyl, the change in the refractive index caused by the azobenzene is enhanced. LCMs undergo polymerization, which frequently initiated by the photopolymerization of acrylate functional groups. This is due to the thermotropic of the liquid crystal materials. Lee and colleagues reported that LCMs can perform initiatorless photopolymerization when exposed to 365 nm UV light. Besides, Liu and Ong studied the diffusion throughout photopolymerization of liquid crystal, where they proposed that their work can be used to evaluate and control photopolymerization-induced monomer diffusion in order to tune the light-triggered topographical morphing.
Last but not least, methodology.
First is material, where prior to the study, 3 different types of liquid crystal monomers are prepared. This study focuses on the analysis of these liquid crystal monomers based on the response towards light. Next is method. The responsive behavior of liquid crystal monomers towards light is observed using UVV spectrophotometer. The absorbance spectra of UVVs are recorded on film cast on quartz substrate at room temperature. The absorbance spectra are recorded with concentration of 3.73 times 10 power of -5 of tetrahydrofuran solutions. The UV's absorbance spectra use the spectrophotometer in the 200 to 800 nm range of wavelength. The liquid crystal monomer samples are measured before and immediately after being exposed to UV light. Before the sample being exposed to UV light, the state is known as ground state, while as soon as the sample is exposed to UV light, the state is known as the excited state. The samples are measured for 10 minutes with UV light having wavelength and intensity of 365 and 50, and following this, the samples will be kept in the dark at various intervals, which is being measured until the spectra recover their original shape. That is all for me. Thank you for listening.